हाय गाइस, दिस इज पुनीत एंड यू आर वाचिंग नॉलेजिस्ट। आज हमारी क्लास होने वाली है ऑपरेटिंग सिस्टम क्लास 5। बेसिकली प्रीवियस क्लासों में जैसे कि अभी हम देख चुके हैं टाइप्स ऑफ ऑपरेटिंग सिस्टम, पीसीबी, शेड्यूलिंग एल्गोरिदम, सो ऑन चीज़ों को हमने कहीं ना कहीं कवर कर लिया है। बात होने वाली है आज डेडलॉक की। डेडलॉक क्या है? डेडलॉक वर्सेस स्टारवेशन प्लस डेडलॉक, हाउ टू हैंडल डेडलॉक, डेडलॉक इग्नोरेंस, अवॉइडेंस, प्रिवेंशन, रिकवरी, इन सब के बारे में बात करेंगे। काफी हॉट टॉपिक रहता है ये बेसिकली, आईटी से रिलेटेड डेडलॉक, तो कवर करना जरूरी है। ध्यान दीजिएगा, काफी इंपॉर्टेंट पॉइंट रहते हैं इसके अंदर। तो चलिए शुरू कर रहे हैं डेडलॉक के बारे में। सो बेसिकली डेडलॉक, डेडलॉक होता क्या है, ठीक है ना? सो every process needs some resource to complete its execution. However, the resources granted in a sequential order. The process requests for some resource. OS grants the resource if it is available. Otherwise, let the process wait. The process use it and release on the completion. Okay, तो ये हम जानते हैं, एक ओवरव्यू हमने लिया कि क्या होता है एक प्रोसेस के अंदर। बेसिकली जब भी एक प्रोसेस रन होती है तो कहीं ना कहीं उसे कुछ रिसोर्सेज की नीड होती है, और ये रिसोर्सेज एक सीक्वेंशियल मैनर में एक एक वन बाय वन कहीं ना कहीं अलॉट करे जाते हैं कि हाँ, प्रोसेस 1 है, उसे कोई रिसोर्स चाहिए अलॉट करो, फिर प्रोसेस 2 आई, उसे कोई रिसोर्स चाहिए अलॉट करो, एंड सो ऑन, इस तरीके से चलता रहता है। अगर रिसोर्स अवेलेबल नहीं है तो वेट कंडीशन में डाल दो उसे। जब रिसोर्स अलॉट मतलब फ्री हो जाएगा तो हम इस प्रोसेस को अलॉट कर देंगे, वी विल अलॉट दैट रिसोर्स टू दैट प्रोसेस। ओके, so a deadlock is a situation where each of the computer process wait for a resource which is being assigned to some other process. In this situation, none of the process get executed since the resource it needs is held by some other process which is also waiting for some other resource to be released. अब क्या कहना चाहते हैं? What we are trying to say? Basically, just suppose we have two process, P1 and P2. P1 have a resource A, P2 have a resource B. Okay, and P1 needs this B to complete its process, and P2 needs this A to complete its process. But because P1 is allotted this A resource and P1 is not completed, so A is logged with P1, and vice versa. P2, we have B logged with P2, right? So none of them can be completed. This is deadlock situation where no process is going to be completed because they can't get their needed resource. Okay, then let's see this with the example. Let's assume that there are three processes, P1, P2 and P3, right? P1, P2, P3. There are three different resources, R1, R2, R3. R1 is assigned to P1 and R2 is assigned to P2 and R3 is assigned to P3, right? Okay, then after some time, P1 demands for R1, which is being used by P2, and P1 halts its execution since it can't complete without R2. So P2 demands OS that this R2 should get allotted to him, right? P1 is trying to grab R2, but R2 is already assigned with P2. So P1 can't, uh, OS can't allot R2 to P1. So P1 halts its process because for completion it needs R2, but R2 is not allotted. Therefore, process P1 is in wait condition now, right? Now, P2 also demands for R3, which is being used by P3. So P2 is demanding for R3, but R3 is allotted to P3. So It also goes in weight condition. Then P3 also demand R1, which is being used by P1. Therefore, P3 also stops its execution. P3 also goes in wait condition, right? So each process is in wait condition now. In this scenario, a cycle is being formed among the three processes. None of the process is processing and they are all waiting. The computer become unresponsive since all the process got blocked. So this is deadlock condition, right? It is important. Okay, let's go with deadlock versus starvation. What is deadlock and what is starvation? Basically, deadlock is a situation where no process got blocked and no process proceeds. Basically, deadlock एक ऐसी situation है जिसके अंदर कोई process block नहीं हुई है, कोई process proceed नहीं कर पा रही है. And starvation is a situation where the low priority process got blocked and the high priority process processed. So basically, starvation in which high priority process which are taking longer time are being processed, but the low priority processes they are going to take much less time, but because they have lower priority, that's why they can't get executed. That is starvation. Basically, the low priority process doesn't getting any CPU time or doesn't getting the resource. That is starvation. Deadlock is an infinite waiting. Deadlock infinitely wait करता है, and starvation is a long waiting but not infinite. Starvation क्या है? Basically a long waiting period हो जाता है. Suppose that the high priority process needs approx 120 seconds, right? So for 120 seconds, basically no other low priority process will get executed. That is starvation. Every deadlock is always a starvation. So that is, I think, clear. Every deadlock is a starvation, and every starvation need not to be deadlock. Okay, it can be a deadlock, but like it can be or and it cannot. Okay, the requested resource is blocked by the other process. In deadlock, requested resources are blocked by other processes, or you can say they are allocated to the other processes. The requested resource is continuously be used by the higher priority processes. So like CPU is a resource and that is being used by the higher priority process. So the lower priority process are not getting any CPU time. That is starvation, right? Okay. Deadlock happens when mutual exclusion, hold and wait, no preemption, and circular wait occur simultaneously. This is really important. What are the conditions for deadlock? So basically, deadlock only happens when mutual exclusion, hold and wait, no preemption, and circular wait occurs. Okay, you should remember that. And it occurs in starvation, it occurs due to the uncontrolled priority and resource management. Basically, starvation is happens because poor program. Okay. So necessary conditions for deadlock. What are they? As we talked in the previous classes, what is mutual exclusion, what is preemption, circular wait, hold and wait. Go with that. See all the previous 4 classes. You will understand all these terms. Basically, I'm going to explain in very short. So mutual exclusion. A resource can only be shared in mutual exclusion manner. It implies if two processes cannot use the same resource at the same time. So basically, mutual exclusion, a single resource is shared with only one process is mutual exclusion. Basically, if there are 3 resources A, B, and C, A can be allotted to one process, B can be allotted to one process, and C can be allotted to only one process. That is mutual exclusion. They can't be shared with single process. Like P1 can't share both, right? Or P1 and P2 share them, like, or P1 and P2 will share this C. Okay, this is not possible, right? Then we have hold and wait. A process waits for some resource while holding other resource at the same time. So what is hold and wait? Suppose that a process needs printer for its execution and it gets that, but it needs some other resource too, and that resource is not available. So it will hold that printer with it. It will hold that printer resource with it. It will not free that printer until it gets the other resource. And if some other process needs printer, so printer is not available, that process will also go in the wait condition. That is hold and wait. Then no preemption. Preemption means like terminating a process before the execution completes, right? Okay, so the process which once scheduled will be executed till the completion. No other process can be scheduled by the scheduler meanwhile. So basically, if a process is in wait, then it will continue be in wait. Then circular wait. All the process must be waiting for a resource in a cyclic manner, so that the last process is waiting for the resource which is being held by the first process. So basically, as we talked in the example, P1, P2, P3 are waiting for their respective resources. That is circular wait. So strategies for handling deadlock. What are some strategies for handling the deadlock? First one is deadlock ignorance. Second, deadlock prevention, deadlock avoidance, deadlock detection and recovery. What is deadlock ignorance? Basically, let it happen. Doesn't matter. होता है होने दो. डेडलॉक इग्नोरेंस. हो रहा है होने दो, हमें मतलब नहीं. ठीक है, इग्नोर कर दो. ठीक है. डेडलॉक प्रिवेंशन यानी कि प्रिवेंट करो. डेडलॉक अवॉइडेंस किसी तरीके से इसे अवॉइड करवाओ. ठीक है. एंड डेडलॉक डिटेक्शन एंड रिकवरी, पता करो कि डेडलॉक हुआ है और देन रिकवर इट. So these are some strategies for handling the deadlock. Let's go one by one. First one is deadlock ignorance. So not a good strategy. Deadlock ignorance is the most widely used approach among all the mechanisms. This is being used by many operating systems, mainly for the end user. In this approach, the operating system assumes that deadlock never occurs. It simply ignores deadlock. This approach is best suitable for a single end user system where user uses the system only for browsing and all other non. So just ignore the deadlock, let it happen, doesn't matter. That is deadlock ignorance. Most of the general operating systems perform this. Okay, we are the end users and we are not that important. Basically, we are not an enterprise, we are only an end user, so they let that happen. There is always a trade-off between correctness and performance. The operating system like Windows, Linux mainly focus upon performance. However, the performance of the system decreases if it uses deadlock handling mechanism all the time. If deadlock happens 1 out of 100 times, then it is completely unnecessary to use the deadlock handling mechanism all the time. So just assume that if we are checking the deadlock conditions rapidly, it will take lots of CPU cycles, right? Lots of CPU cycles will be used in checking, detecting the deadlock conditions. And the Windows Linux works on performance basically. They focus on performance. the computer should be responsive. If we are checking the deadlock conditions, then it will be less responsive. That's why they ignore the deadlock completely. In these type of systems, the user has to simply restart the computer in the case of deadlock. Windows, Linux are mainly using this approach. So basically you have examples which operating systems are using deadlock ignorance, right? Remember the examples. And basically in this approach you have to restart your computer, like कंप्यूटर हैंग हो गया वाली कंडीशन, ठीक है, you just have to restart it. Okay, then deadlock prevention, it is important. Deadlock happens only when mutual exclusion, hold and wait, no preemption, circular waits, hold simultaneously. So the four conditions should meet. If it is possible to violate one of the four conditions at any time, then the deadlock can never occur in this system. So just ignore one condition, just prevent one condition, and the deadlock will get prevented, right? If we simulate deadlock with a table which is standing on its four legs, then we can also simulate four legs with the four conditions which when occur simultaneously cause the deadlock. So just imagine a table with or a chair with four legs basically, and four legs are four conditions. If we break one leg, the table or the chair will fall, right? However, if we break one of the legs of the table, then the table will fall definitely. The same happens with deadlock. If we can be able to violate one of the four necessary conditions and doesn't let that occur together, then we can prevent the deadlock. So basically, we just have to prevent one condition. Okay. So first one, by preventing mutual exclusion. How we can prevent mutual exclusion? Mutual sections from the resource point of view is the fact that a resource can never be used by more than one process simultaneously, which is fair enough, but that is the main reason behind the deadlock. If a resource could have been used more than once, but per process at the same time, then the process would have never been waiting for any resource. However, if we can be able to violate resource behaving in this mutual exclusion manner, then the deadlock can be prevented. So basically, we cannot prevent by mutual exclusion. So just think we have a resource R1 and P1 is writing this R1 and P2 is also trying to write, yeah, read this R1. So P1 is writing and P2 is reading, and because P1 is writing, therefore R1 is constantly changing, and P2 will get some garbage data, right? So therefore mutual exclusion should be there. We cannot prevent mutual exclusion. Therefore, we go with spooling. For a device like printer, spooling can work. There is a memory associated with the printer which stores jobs from each of the process into it. Later, printer collects all the jobs and print one of them according to the first come first serve. By using the mechanism, the process doesn't have to wait for the printer and it can continue whatever it was doing. Later, it collects the output when it produced. So basically, spooling is a way by which we can prevent mutual exclusion. What is spooling? Basically, technique in which a memory is required and that memory stores the work which is going to be performed, and that happens in first come first serve manner. Okay. So although spooling can be effective approach to violate mutual exclusion, but it suffers from two kind of problems. This cannot be applied to every resource. Suppose that a printer can have a spool, okay, but a CPU or CPU cannot have spool, or a memory location cannot have spool.
After some point of time, there may arise a race condition between the process to get space in the spool. Suppose that a spool can hold 10 jobs, and if the resource is slow, then this spool will become full very fast, right? 10 jobs, like basically we have processor which are performing really very well, and they can process lots of processes in seconds. Therefore, spool will full in no time. Okay, so we have to prevent hold and wait. How we can prevent that? So hold and wait condition lives when a process holds a resource and waiting for some other resource to complete its task. Deadlock occurs because there can be more than one process which are holding one resource and waiting for other in the cyclic order. However, we have to find out some mechanism by which a process either doesn't hold any resource or doesn't wait. This means a process must be assigned all the necessary resource before the execution starts. A process must not wait for any resource once the execution has been started. So what we are trying to say? Basically, allot the resources before the process starts its working, or allot the resources before it gets executed, right? But there are many difficulties in that. First of all, what resources will it need? That is a problem. Because in a user environment, basically a user tells what a process should be working on. Okay, so this can be implemented practically if a process declares all the resource initially. However, this sounds very practical but can't be done in a computer system because a process can't determine necessary resource initially. Suppose that you are working with the MS Office, and sometimes you open a file, you edit it and save it. That's all. So basically, you are using CPU resource and memory resource only, right? We are working with CPU time and memory, but sometimes we will print out also. So at that time, we are using the printer resource also. So how we can determine what the resources will be needed while executing a process? That's the problem over here. So process is the set of instructions which are executed by the CPU. Each of the instruction may demand multiple resources at the multiple times. The need cannot be fixed by the OS. So as it explains, what is a process? Process is a set of instructions basically, or program is a set of instructions which are executed by the CPU. Each instruction can demand multiple resource, no resource, single resource, anything is possible. Okay, but it cannot be fixed by the OS. It is fixed by the programmer itself. Okay, then prevent by no preemption. Okay, so deadlock arises due to the fact that the process cannot be stopped once it starts. So deadlock arises due to the fact that process cannot be stopped once it starts. So याद रखें क्या कहना चाहते हैं? कोई भी प्रोसेस स्टॉप नहीं करी जा सकती है जब वो एक बार स्टार्ट हो चुकी है तो, until it get executed completely. However, if we take the resource away from the process which is causing deadlock, then we can prevent that. Basically, if we grab that resource back, then what will happen? Process will get terminated, right? Because it cannot work now. It doesn't have that resources which it needs. Okay, but this can prevent deadlock, right? But this is not a good approach at all, since if we take a resource away which is being used by the process, then all the work which is done till now can become inconsistent. Suppose that A process is printing, a or you can say a process is writing some memory locations, but we take that resource back. We say that you cannot print right now, or you cannot read or write that memory location. We are taking these resources back. What will happen? Basically, all the work, suppose that you have printed 50 of the pages through the printer, and we grab that resource in between. So all the work can be disturbed, right? And the page that is currently being printed can also be disturbed. Consider a printer is being used by one process. If we take the printer away from the process and assign it to some other process, then all the data which has been printed can become inconsistent and ineffective. And also the fact that the process can't start printing again from where it has left, which cause performance efficiency. So basically, suppose that you are printing a photo and you take that resource while printing 50% of the photo, right? We have printed 50% photo, 50% is left, and take that printer resource back. Now printing is stuck in the 50% manner. Can any other process complete it? No. And this 50%, that is total waste now, because we need full photo, right? And if the process gets its resource back, suppose that it gets its printing resource back, then it cannot start with 50%. It should start with the 0% round, right? So that is also not possible. So we have to prevent the circular wait. To violate circular wait, we can assign a priority number to each of the resource. A process cannot request for a lesser priority. This ensures that not a single process can request a resource which is being utilized by some other process and no cycle will form. So basically, we are going to assign a priority number to the resource also to prevent deadlock. Okay, or you can say to prevent circular wait condition. So it can ensure that not a single process can request a resource which is being utilized by some other process. So basically, we cannot prevent mutual exclusion, we cannot prevent hold and wait, we cannot prevent total preemption, but we can prevent circular wait, right? So we have to prevent it to prevent deadlock. Among all the methods, violating circular wait is the only approach that can be implemented practically. So we have to take it very seriously. If the question is there for preventing a deadlock, which condition you should prevent? Basically, there are 4 conditions like mutual exclusion, hold and wait, no preemption, and circular wait, or none of these, right? So we have to prevent circular wait. That's the right answer. Then the third point, the deadlock avoidance. How we can avoid a deadlock? In deadlock avoidance, the request of any resource will be granted if the resulting state of the system doesn't cause deadlock in the system. The state of the system will continuously be checked for a safe and unsafe state. So, whenever a process is requesting a resource, first the CPU will check if I allow this resource to this process, will it take the system in deadlock state or not, right? It will check first, then allow the resource. Okay. In order to avoid deadlock, the process must tell OS the maximum number of resources a process can request to complete its execution. So basically, for preventing the deadlock, the process should tell the number of resources, or we should say the maximum number of resources it is going to ask for, right? The simplest and most useful approach states that the process should declare the maximum number of resources for each type it may ever need. The deadlock avoidance algorithm examines the resource allocates so that there can never be circular weight condition. Basically, simplest approach is that a process should declare the maximum number of resources. Okay. A state of the system is called safe if the system can allocate all the resource requested by all the processes without entering into deadlock. So we will call the system safe if all the processes asking all the resources will not take the system into deadlock state. अगर सभी प्रोसेसेस के सभी रिसोर्स अलॉट भी कर दिए जाएं, तब भी जो हमारा कंप्यूटर है वो डेडलॉक की स्थिति में ना जाए, उसको हम क्या कहेंगे, सेफ स्टेट कहेंगे. If the system cannot fulfill the request of all processes, that the state of the system is called unsafe. अगर सिस्टम ये सारी रिक्वेस्ट को फुलफिल नहीं कर सकता है, किसी एक प्रोसेस की वो सारी की सारी रिसोर्सेज अलॉट नहीं कर सकता है, तो इस स्टेट को अनसेफ स्टेट कहेंगे. The key of deadlock avoidance approach is when the request is made from resources, then the request must only be approved in the case if the resulting state is also a safe state. So basically, deadlock avoidance की key क्या है? What is the key of deadlock avoidance? Basically, when the request is made for resource, जब भी एक request आती है रिसोर्स की, कोई भी एक रिसोर्स अलॉट करने की, then the request must only be approved in case if the resulting state is also a safe state. So वो तभी उसे अलॉट होना चाहिए जिसके बाद कभी भी डेडलॉक ना हो पाए. अगर डेडलॉक की स्थिति बन सकती है तो वो अलॉट नहीं होना चाहिए बेसिकली. ओके, let's talk about resource allocation graph. So the resource allocation graph, RAG, the resource allocation graph is the pictorial representation of the state of a system. As its name suggests, the resource allocation graph is the complete information about all the processes which are holding some resource or waiting for some resource. Basically, resource allocation graph क्या है? What is resource allocation graph? एक पिक्टोरियल रिप्रेजेंटेशन है. जो ग्राफ होते हैं, बेसिकली ग्राफ क्या होते हैं? पिक्टोरियल रिप्रेजेंटेशन होता है किसी चीज की. ये बेसिकली स्टेट ऑफ द सिस्टम की पिक्टोरियल रिप्रेजेंटेशन है, यानी कि जो रिसोर्सेज हैं वो अलॉट होने के बाद उसका एक पिक्टोरियल रिप्रेजेंटेशन दिखाता है. So basically it is a complete information about the processes which are holding some resource, so or waiting for some resource. So basically ये एक पिक्टोरियल रिप्रेजेंटेशन हो जाता है कि किस प्रोसेस को कौन कौन से रिसोर्स अलॉट किए गए हैं एंड किस प्रोसेस को कौन कौन से रिसोर्स का वेट है. ठीक है, ये हमारा क्या हो जाता है? रिसोर्स एलोकेशन ग्राफ हो जाता है. जैसे कि यहाँ पे आप देख सकते हो वर्टेक्सेस है, उसमें प्रोसेस वर्टेक्स है, रिसोर्स वर्टेक्स है. प्रोसेस में बेसिकली P1 है एंड रिसोर्स में सिंगल इंस्टेंस एंड मल्टीपल इंस्टेंस है, बेसिकली CPU और रजिस्टर्स. तो ये इस टाइप का दिखने वाला एक रिसोर्स एलोकेशन ग्राफ बनाया जाता है. समथिंग लाइक दिस, नॉट कंप्लीटली दिस, it is very big for our operating system. Basically we cannot explain the total complete system resource allocation graph on a single page, but it is an example. Okay, then deadlock detection using resource allocation graph, RAG. So if a cycle is being formed in a resource allocation graph where all the resource have the single instance, then the system is deadlocked. In case of resource allocation graph with multiple instance resource types, cycle is a necessary condition of deadlock, but not the sufficient condition. So basically हम क्या कहना चाहते हैं, हम एक साइकिल फॉर्म होता हुआ देख पाएंगे अगर हम रिसोर्स एलोकेशन ग्राफ बनाए तो, राइट. एज यू कैन सी, बेसिकली there are three processes P1, P2 and P3. They have allotted R1, R2, R3 respectively, and R1 is going to be allotted to P2 and R2 is allotted to be going to be allotted to P3 and R3 is going to be allotted to P1, right? So cycle is a necessary condition for deadlock but not the sufficient condition. Basically necessary तो है, होनी तो चाहिए, लेकिन sufficient नहीं है कि हाँ सिर्फ अगर ऐसा हो रहा है तो हो ही जाएगा. ठीक है, कि साइकिल फॉर्म हो रही है तो डेडलॉक होगा ही होगा. That is not necessary. There are as we told, there are 4 types of conditions that should happen, right? So if only a cycle is formed, then it is not necessary that a deadlock will occur. Okay, and the following example contains 3 processes P1, P2, P3 and 3 resources R1, R2, R3. All the resources are having single instance each. So basically the example is simple. Just prevent the cycle that is necessary but not, basically if a cycle is going to be formed, then it is not mandatory that a deadlock will happen. Okay, deadlock detection and recovery. How we can detect the deadlock and recover it? In this approach, the OS doesn't apply any mechanism to avoid or prevent the deadlock. Therefore, the system considers that the deadlock will definitely occur. In order to get rid of deadlock, the OS periodically checks the system for any deadlock. In case it finds any of the deadlock, then OS will recover the system using some recovery techniques. So approach is really simple. Basically, OS doesn't going to apply any mechanism for avoiding or preventing the deadlock because they are really resource heavy, right? So the system will check for the deadlock time to time, basically periodically. Okay, if it finds that a deadlock is happening right now, then it will start recovering the deadlock. The main task of the OS is detecting the deadlock. The OS can detect the deadlock with the help of resource allocation. So the OS will see the resource allocation graph and check if there is any deadlock is happening or not. Okay. Then what is single instance and multiple instance? It is also important. In single instance resource type, if a cycle is being formed in the system, then there will definitely be a deadlock. On the other hand, in multiple instance resource type graph, detecting a cycle is not just enough. We have to apply the safety algorithm on the system by converting the resource allocation graph into the allocation matrix and request matrix. In order to recover the system from deadlock, either OS considers resource or process. So, सिंगल इंस्टेंस एंड मल्टीपल इंस्टेंस क्या है? अगर मान लो सिंगल इंस्टेंस यानी कि एक रिसोर्स को एक ही बार यूज किया जा सकता है, बेसिकली जैसे कि सपोज दैट if we have a memory location, right? There is a block of memory called M1. There is a block of memory called M1, and there are two processes, P1 and P2. P1 wants to read M1, P2 wants to read M1. No problem. Very simple. Both can read that. Both can read the memory location M1. Multiple instance, right? No problem in this. But suppose that P1 wants to write and P2 wants to read, or P2 also wants to write. Is it possible that two processes are trying to write a single memory location? What will happen, right? You know the data will become inconsistent. Therefore, for writing down the data, we need a single instance, but for reading, it can be a multiple instance. Okay. So, in single instance resource type, if a cycle is being formed in the system, then there will be definitely a deadlock. If the system is single instance type and a cycle is forming, so it will always occur deadlock. Just remember that. But in a multi-instance resource type graph, detecting a cycle is not just enough. If a cycle is forming, then it is not necessary that it is going to be, there is going to be a deadlock. Okay, just remember that. Okay, for resources, preempt the resource. We can snatch one of the resource from the owner of the resource, which is a process, and give it to the other process with the expectation that it will complete the execution and will release that resource sooner, while choosing a resource which will be snatched is going to be a bit difficult. So basically, we can prevent deadlock by preemptive a resource. Let's just grab a resource from P2 and assign it to some other process, so that other process can complete its process and the no deadlock condition will arise. Okay, and the other way is roll back to the safe state. Okay, what are these basically? These are recovery method, how you can recover the deadlock. Okay, basically you can recover a deadlock by preemptive the resource and roll back to the safe state. So system passes through various states to get into the deadlock state. This operating system can roll back the system to the previous state or safe state. For its purpose, OS needs to implement check pointing at every state. So basically, we have to roll back to some previous state. There is a rollback mechanism in the process system, basically execution system. The OS can roll back the system to the previous safe state. Okay. The moment we get into deadlock, we will roll back all the allocation to get into the previous state. Okay? Basically, we are going to neglect all the latest work and go back to the safe state where there is no deadlock right now. Okay. Then kill a process. There is also a recovery mechanism in which we can kill a process. So killing a process can solve our problem, but the bigger concern is to decide which process is to kill. Generally, operating system kills a process which has done least amount of work until now. So basically, killing a process is also a difficult task. Suppose that you are a process is working for 2 hours in the background and that got cancelled or killed, and this 2 hour work is also got killed basically, right? It is going to be disappear now, or it will not be sufficient for further use. So killing a process is difficult. Basically, we have to choose the smallest process that is working right now. Okay. Kill all process. Simple. This is not a suggestible approach, but can be implemented if the problem becomes very serious. Killing all process will lead to inefficiency in the system because all the process will execute again from start. So basically, the simplest method for recovery, close each process and restart them. Basically, simple. All the processes will get killed and all the processes will get re-executed. That is kill all processes. So that's all for today guys. I hope आप सभी को क्लास में मजा आया होगा. मजा आया हो तो लाइक और सब्सक्राइब करना बिल्कुल भूलिएगा. मिलते हैं नेक्स्ट क्लास में. गुड नाइट.